CES525, Introduction of Prestressed and Precast Concrete. Concept and principle of prestressed concrete. What is prestressed concrete? Prestressed concrete is a structural material that allows for predetermined engineering stresses to be placed in members to counteract the stresses that occur when they are subject to loading. It combines the high-strength compressive properties of concrete with high tensile strength of steel. Principle of prestressed concrete. In concrete, a large prestressing force is applied by tendons embedded into it. The anchoring devices are generally designed for high-strength concrete work. Too high stresses are likely to be developing in concrete members and that cannot be satisfactorily resisted by low-strength concrete work. Stress transfer to concrete is done by in between concrete and tendons. The concrete should have a high-strength concrete. Shrinkage cracks will occur during the safer of stresses from tendon to concrete. High-strength concrete has a high modulus of elasticity, and therefore the elastic and creep strain are very small, resulting in smaller loss of prestress in all steel reinforcement. Prestressed concrete video.
Prestressed concrete. In case of big concrete construction projects like bridges, steel reinforcement bars alone won't be sufficient to provide the necessary tensile strength. In this case, prestressed concrete is being used. In prestressing, the rods or tendons are stretched along the axis and cement is poured. Later, when the tendons are released, the compression is generated at the bottom, which tries to counterbalance the compression due to loading at the top part of the beam. The principle behind prestressed concrete is that compressive stresses induced by the high-strength steel tendons in a concrete member before loads are applied. This will balance the stresses imposed in the member during the service. Prestressed concrete can be used for the construction of roofs, floors, walls, and bridges with longer unsupported spans. Prestressing is generally done by two methods: pre-tensioned concrete and post-tensioned concrete. Pre-tensioned concrete. Pre-tensioned concrete is those in which the tendons are tensioned before pouring of concrete. The tendons are initially tensioned and anchored at both ends, and then concrete is poured over it and cured. When the concrete attains desired strength, the tendons are released and projections are cut out. The prestress imparts into beam through bond action. Post-tensioned concrete. In post-tensioned concrete, the tendons are tensions after the concrete is poured. Initially, the concrete is cast around the sheathing. The ducts are formed in concrete in which tendons are placed. After the concrete is hardened, the tendons are tensioned by hydraulic jacks and anchored. In case of bonded type tendons, the duct is grouted with sufficient slurry. In the unbounded type of tendons, grouting is not necessary. We will learn about this later. Thank you for watching. Stay tuned. The best is yet to come.
Prestressed concrete is prepared by the two methods. First one is pre-tensioned concrete, and second one is post-tensioning concrete. Never be confused between the prestressed concrete and pre-tensioning concrete, because pre-tensioned is the method to prepare prestressed concrete. In pre-tensioned concrete, Firstly, steel wires are pulled, which will further act to produce compressive stress. After stretching of the steel wires, concreting is done. When concrete achieve its characteristic strength, then the grip of steel wires are removed. As we remove the wire grip, it tries to compress the concrete, which produce compressive stress in the bottom of beam. In post-tensioning concrete, a beam is casted firstly. During the casting, pipes are provided at the tension zone of the beam, which is at bottom for a simply supported beam. When concrete achieve its characteristic strength, then steel wires are inserted in these holes. Then these wires are stretched using hydraulic machines. After stretching, these wires are hauled up at the end and filled with the concrete. The principle of post-tensioning beam is same as the pre-tensioned beam.
Precast concrete versus conventional in situ construction method.
Concrete has some weaknesses too. One that we've discussed in previous videos is that it has almost no strength against tension. Concrete can withstand a tremendous amount of compressive stress, but when you try to pull it apart, it gives up easily. Concrete's other weakness is that it's brittle. It doesn't have any give or stretch or ductility. Combine these two weaknesses and you get cracks. Concrete loves to crack. And if you're designing or building something made of concrete, understanding how much and where it's going to crack can be the difference between the success and failure of your structure. In the case of concrete, deflection has another impact: cracks. The reinforcement within concrete is usually made from steel, and steel is much more elastic than concrete. So in order to mobilize the strength of the steel, first it has to stretch out a little bit. But unlike steel, concrete is brittle. It doesn't stretch, it cracks. So that often means that concrete has to crack before the rebar can take up any of the tensile stress of the member. This demonstration is from a test in a previous video showing a conventionally reinforced concrete beam. Go back and check out that video if you haven't seen it yet. Notice how the beam is resisting the load on it even though it's cracked at the bottom. It's meeting design criteria number 1, it's holding the load, in this case 6 tons, without failing. But it's not meeting design criteria number 2, serviceability. It's deflecting too much, and the concrete is cracked. Those cracks not only look bad, but in an actual structure they could allow water and contaminants into contact with the reinforcement, eventually causing it to corrode, weaken, and even fail.
Precast concrete. Precast concrete is made in a place other than the building site, like a factory, where it is molded into a certain shape. The concrete is put into a mold, which is usually made of wood or steel, and left to harden. Then, these parts are taken to the construction site and put together there. Concrete can be made in a plant or on-site. Cast in situ concrete. Cast in situ concrete is poured into molds on the construction site. It gives the designer an infinite number of ways to make any shape, and there are an infinite number of surface textures to choose from. Environmental effect. Prestressed concrete. Prestressed concrete members are free from cracks and the resistance to the effect of impact, shock, and stresses are higher than reinforced concrete structures. High compressive strength of concrete and high tensile strength of steel are used for prestressing that makes it more economical. Prestressed members are lighter in weight and easily transportable. Precast concrete. With precast's high thermal mass, a building can be designed with minimal need for artificial heating and cooling. The stability of precast over its life delivers an environment free of fumes and chemicals. And there's no need for chemical treatment up front or later on. In Precast's case, the carbon that is produced during the manufacture of cement is offset, with minimal maintenance costs, lower heating and cooling costs, and the concrete reabsorbing up to 40% of the carbon over the structure's life. In addition, there's minimal waste during manufacture and what are otherwise waste products like fly ash and slag are used. At the end of its life, precast structures can be fully recycled. Being manufactured in a factory-controlled environment, manufacturing precast employs advanced technologies and reusable steel molds, resulting in high-quality products and less waste.